So distribute on the one side, start solving for x. As you start solving, you'll see that you have the same constant and the same coefficient, even though they're switched. So at that point in time, you could stop solving. You would get that these have infinitely many solutions.
What? No, I did it wrong.
Or you could have kept solving, and you would have got either 0 equals 0 or 6 equals 6. Either way, that is a true statement, so this would still be infinitely many solutions.
Oh, I thought I was supposed to add the 6 and 6 after I times the 6 and find a 3.
No, because they're not like yours. If they were both x's, then yes, that'd be the case. Really quickly for number 2, it's asking for your domain and range. So domain is your furthest point to the left to furthest point to the right, and you can write this one of two ways. In set builder notation from -3 to 2, or interval notation, which we're going to learn a little bit more today about, from -3 to 2 with square brackets. And then your range is your lowest to highest. So your lowest would be -1, your highest is 3. So in set builder notation, then it would look like this. In interval notation, it would look like this in square brackets. Okay. We'll continue the other 3 when we get back from lunch. For the third one, it is up on the board. You had 2 fractions that equal each other, so you needed to cross multiply. It doesn't matter if you put this on this side or vice versa. Distribute and start solving for A. Move all the A's to one side and then the constants to the other. And then as you're solving this, you would get A equals -14. Questions on that one? On the back, the fourth one you had to evaluate. It says f of 9. So you're going to put 9 in for x, wherever x is, and simplify. So if you put 9 in where x is, and add those together, you get 16. Square root of 16 is 4. 2 is next to that, so multiply. So f of 9 equals 8, or f of x equals 8. Either one of those answers was acceptable. Number 5 was a little bit complex because it has all these fractions. You needed to distribute. And then once you distribute, you end up with 3/4 x, and combine like terms. 3/4 x plus 3/3, which simplifies to just 1. This looks more like a normal equation. You can start to solve it. Subtract 1 from both sides. Multiply both sides by the reciprocal, 4/3, and you would get -8. Questions on that one? Okay. So a few things before we start our notes for today. One, we are starting a new unit today. This is going to be the last unit that gets put on the second marking period. So and this will take us into winter break. So when we come back from winter break in January, we will start a new unit, and that new unit will be put on the third marking period. Even though the third marking period doesn't start until the end of January. But I'll remind you that again later. If you have not taken any tests, so Unit 2B, Unit 3, and then this test when we go to take that, you should not go into winter break or into the next year with those missing tests. Make sure you get those done before winter break. So this next unit we're going to do is on inequalities. A lot of the stuff we do in this unit is going to be similar things we've already talked about, but with a small twist. So like when we are solving inequalities, how we solve equations will be very similar, just with slight differences, how we answer them. When we get into graphing inequalities, how we graph equations will be very similar, but it'll be a little bit different. And then how we get into systems of inequalities will look very similar to how we did systems of graphs, but a little different. So a lot of this will be familiar to you, but also a little different.
The system of inequalities is not n meaning not equality, then you're back to equal. Because it's equal, so it's not equal. So in a general sense, that's what we're looking for. Why are they not equal?
Unless you get greater than or equal to or less than or equal to. Did you have a question?
Yeah, is this formal? Is this what? Online?
Are the notes online?
Yeah.
Notes are always posted online.
When exactly?
There's a notes page. Find that, you'll find the notes. Okay. So to start off these, some of this may be familiar to you from when you learned inequalities, whenever that was. We're going to use an open circle for strictly less than or strictly greater than signs. And a closed circle for less than or equal to or greater than or equal to signs. So if it has the line underneath the inequality to mean it's equal, we're using a closed circle is included. If it does not have that equal to, it is not included. It is not also equal to, so it would be open. So we're going to do just a few of these. These first examples, these would be like you solved the problem already and then you get this answer. So I'm going to start at number 2, where it says x is greater than -1. Would that be an open or a closed circle? Open. At -1. For the most part with these, you can look at the direction it's pointing. So this is pointing to the right, so I have to go to the right. But we have to be careful with that, depending on how it's written. Because if it was written flipped, so like this, this would read -1 is less than x, but it means the same thing as x is greater than -1. It's just flipped. However, in this case, we would not draw it this way. It would still go this way. So be careful if you're looking at the direction in which it's pointing, the inequality is pointing. For number 3, x is greater than or equal to 7. Would that be an open or a closed circle? Closed. So you're going to, at 7, like, kind of fill it in. Everything greater than or equal to 7 would be going to the right. So we would draw an arrow to the right. Do you have any questions on that part so far? Another way you may see like what is the inequality if it gives you the graph, but then you have to find the answer. Let's say we were doing number 8. Ignore that these written numbers. I don't know if you guys use this or view these at all, but there are go-formative notes for every set of notes I pass out. Just to kind of do the same thing, but on go-formative to get instant answers. That's what these numbers are for. There's nowhere to go that. So if we were doing number 8, what would this inequality be? Kobe?
X is
Yeah. X is strictly greater than -3 because it's an open circle. We have to have greater than or less than, and because it's pointing to the right, it has to be greater than. And then it's at -3. Okay, so now to actually get into the solving part.
I can't find those.
Are you in the unit 4, lesson 1, notes? It would be probably easier if you just follow the ball.
Yeah, I guess before that.
So if there's not a typing option, there, yes.
Oh yeah, I can still, I can convert it to.
So I can show you later, but now you should probably follow along right here. So for ignore this number. For this, you must switch or flip the inequality symbol when you multiply or divide by a negative number. And I'm going to give you a few examples. So if you had something like -4x is greater than -4, you don't have to write these examples, but you definitely can if you want to. If this usually happens like at the last step when you're trying to get x, y, and self. If I have something like this, see, let's just put this, and I'm dividing both sides by a negative, this sign would change direction because I divided by that negative. Magically it happens, always it happens. However, if I were doing the same thing, but I'm dividing by a number and there is a negative, so I'm not dividing by a negative, but there is a negative there, that would not change the sign. So if you were actually dividing by a negative, the sign would change, but if there happens to be a negative already there, you're not changing the sign. Multiplying happens very rarely, but it does happen. So if you had a multiplying example, it would be something like x over negative some number, and you're trying to get x by itself, you would multiply both sides by that -2. And because we multiplied both sides by that negative, the sign would then change. However, just like the other example, if I had a negative on the other side, but I'm not multiplying by a negative, the sign would not change. So be very careful with that. Do you have any questions on that part before we actually do some examples? We're going to do this number 9. So when you do these, you're going to think about them as how would I solve it as if it were an equation and do it the same way. You can pretend that this is an equal sign for a moment. Don't actually change it to an equal sign, but think about it like it was an equal sign. How would I solve this? Well, I would get rid of 2 first. So subtract 2 on both sides. Keep your sign. Make sure it's the same all the way throughout. Make sure you don't lose it or turn it into an equal sign throughout. And then get x by itself by dividing. Would my sign change here? No, because I didn't divide by a negative. There was already a negative. And then you have blank number lines, so you can kind of make up your own. I usually put whatever this number is in the middle. and then kind of spread out from there. So going to the right, that would be -1, 0, 1. Going to the left, that would be -3, -4, -5. Would this be an open or a closed circle? Open. At -2. And then going to the left or to the right? I hear a voice that is actually there. Yes, to the left. So that would be us solving the inequality and putting the answer by graphing it. Do we have any questions on how we got that answer, graphed it, solved it, anything like that? Like I mentioned before, the process is very much the same as solving an equation. It's just a little bit different because of how we write our answer. We're going to skip around a little bit. Go on to the next page. So we talked a little bit about interval notation when we were doing domain and range. It's kind of the same thing. So I'm going to read this and then we'll talk more about it. Interval notation is another way of expressing the answer to an inequality. It uses parentheses and brackets to show where the graph starts and ends. So because we're just looking at, we're getting like an x is greater than or less than something, we're really just looking at our domain right now. So when we are writing this, we're looking at furthest point to the left to furthest point to the right. And a lot of our answers like start at some number, but it says like x is greater than 2. That means it starts at 2, but then it keeps going all the way to the right towards positive infinity. Or if it said x is less than 2, it would start at negative infinity and then go to 2 itself. When we have just strictly less than or strictly greater than, we're going to use parentheses. Think about that as you're not included, your open circle, all of those things go together. When we have greater than or equal to or less than or equal to, we're going to use square brackets. But when we go to positive or negative infinity, no matter which one that is, we always use parentheses. We're going to do a few examples where we're now using this interval notation. Basically what we were writing before was set builder notation, the x is greater than 2 or whatever. So for this number 1, we would solve this like normal. You could either distribute or divide both sides by 4, since 4 is a factor of -24. Doesn't really matter which one you do. I'm going to distribute though. And start solving this for x. Subtract 12 on both sides. And divide both sides by 4. Would the sign change here? No, because we did not divide by a negative. So it doesn't really matter if you graph it first and then do interval notation or vice versa. We're going to graph this first and then do interval notation, and then on the next one we'll do the opposite. So I'm going to put this in the middle and spread out. So this would be -8, -7, -6. And then, sorry, that should be 4. I'm sorry again. Nope, that was right. I was looking at the wrong thing. And then -10, -11, -12. This would be an open circle at -9, going to the right, everything greater than -9. So when we write this in interval notation, we're looking at the number we start at, which would be -9. -9 has an open circle, or we're using a strictly greater than, so we're going to use a parenthesis at -9. And this keeps going all the way to the right to infinity and beyond, so this would be to infinity. And we'd also use a parenthesis. So this is saying these two things are basically saying the same thing. Do we have any questions on how we wrote interval notation, graph that, solve that? Let's do another example. Let's jump down to number 4 on this page. So again, same thing, we're going to solve this just like all the other ones by distributing. So -8x plus 8 minus x is less than or equal to -28. Combine your like terms. This would give us -9x. And then we could continue solving, subtract 8 from both sides. And divide. In this case, is our sign going to change? Yes. So we'll flip directions. If you don't change directions, your answer is going to end up wrong. So be very careful. So I can put 4 in the middle here and kind of spread out. So 5, 6, 7, 3, 2, 1. This would be a closed circle because it's included. And this would point to the right. And then when we do the interval notation, I said we were going to switch these. It's all right. Like I said before, it doesn't matter whether you do the graph and then the interval notation. If you do the graph first, it kind of helps you visualize for the interval notation better. But had this not been here and I just looked at this, x is greater than or equal to 4. I know it's going to start at 4 and keep going to the right. 4 is included, so that would be a square bracket. And it's going to keep going all the way to positive infinity. That was not good at putting symbol. Sure. But that one would have a parenthesis. Because infinities are always parentheses. Do we have any questions so far? We're going to do one more example together, then I'm going to let you guys practice. On the next page, let's come all the way down to number 9. Because this is like the most complex this is going to get. It's like solving two-sided equations or variables, equations with variables on both sides. Here, I would distribute on both sides. Let's see. Remember that this is really -1. So doing all of that, we have 5x minus 3x minus 18 is greater than or equal to 8 minus x plus 7. Combine like terms on the same side. 5x minus 3x gives us 2x. Make sure you're bringing down your symbol. 8 plus 7 gives us 15. Then you can start moving things. Remember, your sign doesn't change unless you multiply or divide by a negative. So I could add this x over here and add this 18 over here to get 3x is greater than or equal to 33. 31, 35. And divide both sides by 3. And then once you have that, you could find your interval notation and graph it. This is going to start at 11. And it's included. So it's going to be a square bracket, 11. And it's going to keep going towards positive infinity. And then when I graph it, I'm going to put 11 in the middle and fill out that number line. This is going to be a filled in or a closed circle with an arrow going to the right. Yeah, yeah, so all of the examples happen to be that, but had this been the other way, so let's say it was this, then it would start here and go this way, but instead of this, we would start at negative infinity, because that's the lowest. So this would be from negative infinity, but it stops at 11, so it would go to 11. It would just be the opposite way around. If it was this, it would just be the other way. Right. Anyone have any other questions before I give you time to practice? So in the next 15 minutes, I want you to practice the ones we haven't done in these notes, and then at 12, I'll have you guys switch gears and do Delta Math Khan Academy unless you finish before that. So in these notes, there is one on the first page, number 10. Actually, sorry, that was incorrect. There are these that we didn't do as well. 1, 4, 5, 6, 7, and then 10. But those are easier. And then on the second page, 2 and 3. And on the last page, 5 through 8, and then number 10. So do as many as you can of those in the next 15 minutes. And then at 12, I'll have you guys switch gears and do the one Khan Academy and Delta Math. If you have any questions, we'll be walking around. But you have this time to work.